For decades, missionary organizations have been using pilots to reach places in the world that were previously impossible to reach. This means flying into extremely remote and often unfamiliar terrain. Because these airstrips are not regularly used, they are usually not documented very well, if at all. This lack of information, combined with the fact that these airstrips are not well maintained, which allows for vegetation to grow up all over the place, can cause dangerous landing conditions for new and even experienced pilots. It wasn't until recently that technology had advanced far enough for us to offer up a cheap and easy solution to this problem: drones. Drone cameras and sensors have continued to improve over time, while their prices have continued to drop, to the point where drone mapping can produce a high-quality map without breaking the bank. The only problem is that there are so many drones and mapping software options out there that none of these missionary groups have the time to go through and figure out which combination is best, and that's where we come in. But who are we? We are Falcon UAV. Hello, my name is Jeffrey McClary, and I am the Student Project Manager for the Falcon UAV team. Our team has been tasked with wading through the vast ocean of drones and drone mapping software options to find the combination that balances quality and price to make the perfect mapping system for missionary aviators. After thorough research in the fall of 2019, the Falcon UAV team has decided that by combining the DJI Mavic Pro Platinum with the drone mapping service Drone Deploy, we will have the best combination of map quality and overall cost. Our team has been working directly with iTech, an organization founded by Steve Saint, the son of the martyred missionary pilot Nate Saint. Through this collaboration, we have been able to receive expert feedback in order to perfect our system, as well as being able to develop a set of tutorial videos and an instruction manual, which will then be handed over to the missionary aviation community in order to provide better documentation and, more importantly, safer flying conditions for these pilots flying into these remote locations.
Hello, my name is Micah Lehman. I'm part of the Falcon UAV team at Messiah College. The bulk of our task was to determine if it is feasible to use a drone to survey airstrips and what the capabilities and limitations of that system are. Our process is to use the drone to take pictures of the airstrip and surrounding area. We then upload the images to our software, Drone Deploy, which uses the photos to create a 3D map and digital surface model. The user can then use the digital surface model to gather the information necessary for landing a plane on the runway. In order to determine the feasibility of using a drone for this process, we needed to conduct tests to get an idea of the accuracy of the measurements made by our mapping system, and the ability of our system to detect small runway obstacles. The testing process for measurement error involved comparing actual measurements to measurements made by Drone Deploy while changing only the pixel density of the map. The results of this experiment showed that our error in height measurement was less than 9%. Testing the ability of our system to detect runway obstacles involved putting a variety of objects and holes inside the mapping area while doing several maps at different pixel densities. The results showed that our system can detect all our objects harmful to the aircraft if our drone is flown 150 feet from the ground or lower.
Hi, my name is Kyle Miller, and I am a senior year mechanical engineering student on the Falcon UAV team. Part of our tasking on the Falcon UAV team involves solving various technical problems with our system. In engineering, it is very common that when you acquire a new system or tool, you are bound to come across various problems that either have to be fixed or a workaround has to be produced. One of the first technical issues that we experienced dealt with the presence of optical illusions that ended up disrupting our mapping process. On our first flight with our system, the Mavic Pro Platinum, we kept a protective cover over the camera's gimbal system. Unfortunately, flying with the protective cover over the camera system had the adverse effect of producing glare from the sun at certain angles during the flight. And during the uploading process for all the photometric data, the glare ended up affecting the mapping process very negatively. Effectively, what ended up happening was many of the pixels were not splicing together. The map looked very washed out. Many of the geographic features weren't showing up clearly. Parts of the ground weren't stitching together, and overall, it was just very terrible data presentation. On subsequent flights, we had decided as a team to remove the gimbal cover altogether and see how that would affect our data. We never had this issue again with any sun glare, and as a result, our data turned out to be a lot better. Another key issue of troubleshooting the team had to deal with was the presence of how weather can affect the flight of the drone. Obviously, you don't want to fly a drone in the middle of inclement weather because water and electronic components don't exactly mix well together. But another point to consider is how wind speeds can affect the drone's flight. It was found through various test flights that wind speeds that exceed 10 to 12 miles per hour can adversely affect the drone's flight path. The main workaround for this issue is to look ahead at future weather reports for days that the user intends to fly. If wind speeds look to be exceeding that 10 to 12 mile per hour cap, then it might not be an ideal day to fly. Furthermore, the team had found that flying early mornings, say around 6 a.m. or 7 a.m., is an ideal period for these wind conditions. This is because early mornings are typically the coolest part of the day, and the coolest parts of the day also have the slowest wind speeds. In either case, it is important for the user to look ahead at weather reports to see what the wind speed is going to look like at the time and location where they will be mapping. Another key issue that this team has faced is the accuracy in our elevation data for our maps. We noticed upon comparing various control points with the points on some of our maps that the elevation data that we had measured with a GPS device that reads altitude did not match up with what Drone Deploy was displaying in its data presentation. This was cause for some concern until we had discovered a calibration feature in Drone Deploy. Once the calibration process is complete, the entire map's elevation data will update relative to that point. This in turn will ensure that the map data will better reflect what a measurable data point will be with a separate device.
The Falcon UAV team has been able to successfully research and develop a system to gather data and create maps with ease, while also developing an instruction manual and a set of tutorial videos that will guide users through our process from start to finish. The team will travel to iTech's Florida location to train iTech members on how to use our process. This will allow them to take that knowledge and train anyone who reaches out to them about using the process in the future. This was only possible due to the continued support of the Collaboratory at Messiah University. Our team would like to thank our faculty project manager, Derek Plant, as well as our former student project manager, Johnny Greaser, for helping us get this project off the ground before he graduated. We would like to give a special thanks to Glenn Ferguson of IAMA and all the members of iTech who regularly took time to meet with us and advise us on how to make our project better. We couldn't have done it without your help. And finally, I'd like to thank all of you for joining us here today. Thank you.